Okay, another round of related weights questions. Sometimes these are referred to as shadow problems. But you're going to see that these are similar triangle problems. Okay, so like always, we need to have a good picture. So we've got a spotlight on the ground. I'm just going to call that our light. And it's shining on a wall, the wall over here, and the wall is 10 meters away. And a man, tall man, he's 2 meters tall, and he's walking that way, away from the spotlight towards the wall. And he's going quite fast. I don't know what kind of thing has startled him. It is strange to see a person running directly towards a wall. This is kind of a strange problem. Okay, we are going to find how his shadow is changing when he is only 3 meters from the wall. Okay, so I'm going to add some dimensions here. The first dimension that I'm going to add is this one. I'm going to call this x. That way we can say that dx dt is 1.2 meters per second. And we'll call this y, and this is the shadow height, and this is what we're supposed to be finding. dy dt when x is 7. Now you might look at that for a moment and say, what do you mean x is 7? Well, when he's 3 meters from the wall, 10 minus 3, 7. So the x would be 7. And this is what we're trying to find. Okay, and so the next thing we need to do after drawing a picture and declaring our rates or stating our rates is we need an equation that's going to connect these things. And a little bit ago, I suggested that these are similar triangle problems. I want you to notice that this man who's 2 meters tall and x form a triangle, and there's the relationship or the proportions, and that would be the same as this would be x over 10 or y over 10. And this is a similar triangle's kind of proportional relationship. I'm just going to simplify it a little bit by saying 20 x to the negative 1 equals y by bringing the 10 over and writing that in its exponent. But now I have an equation. The next step is to differentiate both sides with respect to time. So negative 20x to the negative 2 dx dt is equal to dy dt. And we're supposed to find dy dt when x equals 7. So we'll plug that in, negative 27 squared, and dx dt has been given to us as 1.2 meters per second. And so if I plug that all into my calculator, I get a negative 0.49 meters per second. And the negative is giving us an indication that this is decreasing, and so this kind of makes sense in this context. So I'd like you to try these next two here. They're very similar in the sense that they use similar triangles, but you're going to have to work at them a little bit more to try to figure out what's going on there. Good luck.